Alrighty, I'm at school on a Saturday. Gonna make this video for you guys to go over the benchmark review from last week. All right, so put your names on it. Now, if there's one name on it, you're gonna get 50 points on this no matter what. If there's two or three names, you're gonna have to get at least 40% on the benchmark to get credit. 40%, that's a pretty low F. So if you actually did this yourself and you kind of understand it, you should get higher than 40%. So if you're just copying what I'm doing and don't really understand it, that's really not going to do it for this one, because 50 points on homework is nothing. But 50 points on our benchmark, that's going to be a lot of points for your grade. All right, so here we go. Number one, you're not going to need to know it, so I don't really care if you do this one or not. Provides a tube light. Those are called channel proteins. That's like a door that allows certain things to move in and out of the cell. So it's like a tube. Those are channel proteins. You won't need to know it. Blank is used during active transport. Whenever you're active, you're moving around. This is when things are being moved from low concentration to high concentration, and we need energy. Energy is required for that, to move things where they don't want to go. That requires energy. Remember, passive transport does not require any energy because things are going from high concentration to low. They want to go there anyways, so you don't have to use energy to make them go. Blank is particle movement from high to low concentration. That's diffusion. It's almost the definition of diffusion. The movement of particles or molecules from high concentration to low concentration requiring no energy. 4, a form of passive transport that uses transport proteins. Anytime it's passive transport and it requires a protein, that is facilitated diffusion. Facilitated diffusion. Facilitated diffusion, movement of molecules from high to low, but it requires a protein channel, where simple diffusion does not. It can go straight through anywhere in the cell membrane through the phospholipid bilayer. Particle movement from low to high concentration. Anytime you're moving things from low to high concentration, those things do not want to go there. It's going to require energy. Therefore, it's active transport. Active transport, moving it, spelled it wrong. Active transport, moving things from low concentration to high concentration, requires energy. And this one you won't need to know. This is like a carrier protein, but don't worry about it because you won't need to know it. All right, the drawing on the left. So on the far left right here, we have simple diffusion or just diffusion. These little circles are going straight through the membranes. That's diffusion. On the right side of it, this is facilitated diffusion because they're still going from high concentration to low. Whoa, it says water here. Oh, that's water. I totally missed this. All right, so this is, I've been telling everybody this is passive transport. I couldn't even read that little water. Since it's water, it's osmosis. All right. It's also, those are both passive transport. All right, so this one right here, the triangles are going from high concentration on the top to low concentration on the bottom, but it's using this protein channel. So since it has a protein, it has to go through a protein. That's facilitated. Facilitated. That looks right. Aided. Yeah, there we go. Diffusion. Facilitated diffusion, the movement of substances from high to low concentration through a protein channel. Now, don't be confused on this one. They look very similar. Both have a purple protein, but look, this one's moving them from low concentration to a bunch of them down here, high concentration. Plus, we have this little firework right here. That shows that energy is being used. That's active transport. Active transport. And over here, we got substances, high concentration up here, moving to low concentration. But look, it does not require a protein channel. That's just diffusion. Diffusion. All right, so wow, I cannot believe it took me 2 or 3 days to see water. Anyways, all right, what's the difference between active and passive transport? Active moves substances from low to high concentration and uses energy. Passive moves substances from high to low concentration and uses no energy. Does not require any energy. So there's your two definitions, active transport and passive transport. Active transport moves substances from an area of, remember I just said it just a second ago, low concentration to areas of high concentration. And those substances, those molecules, do not want to go there. So that's why it requires energy, because you got to force them. So it does this by using energy. Energy to move molecules what's called against the concentration gradient. So that means it's moving them against where they want to go. They want to go high to low, but you're moving them low to high, and like, hey, I don't really like that. But with a little energy, you can move them. All right, some pictures. Inside the cell, we have 80% water inside the cell. Outside is 75%. Osmosis, things move from high to low. Since it's higher inside the cell, water is going to move out of the cell. So which way will water move? It's going to move out of the cell. What will happen to the cell? Since water's moving out, it's going to shrink. All right, this one's kind of the opposite because this one tells us how much water. This one's telling us how much salt. NaCl, sodium chloride, that's salt. So inside the cell is 15% salt. Outside the cell is 5% salt. So basically, inside the cell, since it's 15% salt, it's going to be 85% water. So I'll go ahead and write it. 85% water in here. And the outside's 5% salt, so it's going to be 95% water out here. All right, so 95 is higher than 85. So this case, water is going to move into the cell from high to low concentration. So water is going to move in. The cell will grow or get bigger. All right, this one, inside the cell is 65% water. Outside the cell is 85%. So let's go ahead and write it again. 65 in here. 65% water, 85 out here. So this one's pretty simple. Goes from high to low. So this one's going to move into the cell again. So the water is going to move into the cell. And the cell will grow or get bigger. Is osmosis active or passive transport? Osmosis is passive because it requires no energy and moves from high to low concentration. Mosquitoes biting me. Mosquitoes biting me. Give me a second. Get them. All right, I'm back. Well, I didn't get him. He's still going to try to bite me, but here we go. All right, name the three types of passive transport. We got diffusion, facilitated diffusion, and we got osmosis. Those are our three types of active transport. Still looking for that mosquito that bit me on the foot. 18, what kind of protein is used to transport molecules across the membrane during active transport? You will not need to know this. Like a protein pump. You don't need to know that, though, so don't worry about it. All right, negative feedback loop. Let's see what we got here. So I'm not going to read all this because I know it. How do negative feedback loops help to maintain homeostasis? Remember, homeostasis is your body staying like imbalanced. So, for example, like temperature, your body's supposed to be about 99 or 98 degrees Fahrenheit. So if you start getting too hot, your body's going to do the opposite and cool you down. If you start getting too cold, your body's going to do the opposite and heat you up. And that's what a negative feedback system or loop is. Whatever happens in the body, your body's going to do the opposite. So let's see. How do negative feedback loops help to maintain homeostasis? I'm going to give an example. If your body gets too warm, your body will react by cooling you down. Remember, there's two ways basically that the body does this. Number one, I know you know, is sweating. You sweat, that cools you down. But also number two, or dilate your blood vessels. It's called vasodilation. That brings the blood closer to the surface of the skin. And while your sweat is evaporating, that's a cooling process. So when the blood's closer to the skin, that heat can escape your body. And the opposite of that, if you get too cold, your body's going to do the opposite. Your body will warm you up. It does this by shivering, by goosebumps. They have kind of a role because muscles have to contract to give you those goosebumps. Whenever muscles contract, that creates heat. And your blood vessels will constrict. They come smaller. So the blood is not next to the surface, so the heat can't escape. All right, now what are two ways that our body tries to cool down after heating up? I know you know one of them. That's sweating. And remember the other one, blood vessels dilate. Remember when blood vessels dilate? That brings dilate, that's spelled right, isn't it? dilate, the blood comes closer to the surface of the skin and allows it to escape. Explain how the negative feedback loop happens when your body temperature drops too low. All right, remember, negative feedback, it always does the opposite and returns you to normal. Remember that word, normal. Anyways, so what happens if body temperature goes too low? All right, so if it's going low, your body will heat you up by shivering and blood vessel constrict. Still pretty sure that's spelled right? Dilate? I don't know. If you guys figured out how to spell it, let me know. Blood vessels constrict. So that's, and then it returns your temperature, put temp, to normal. Remember that word, normal. Anytime it returns to normal, that's negative feedback. Let's see, is it going positive? No, it's not. Okay, positive feedback. All right, so here's your picture of negative feedback. Body temperature goes up, hey, it cools you off. Body temperature goes down, and it heats you up. Positive feedback is the opposite. So negative feedback returns you to normal. And positive feedback, positive, 1S. Positive feedback makes whatever is happening happen even more, or happen even stronger. So remember, I gave the example of child or labor contractions when a woman is having a baby. Well, when she has a contraction, that causes a hormone to be released, which causes more contractions, which causes more hormones, which causes more contractions. So it just keeps going up. It doesn't return it to normal. It just keeps going up. Okay, we got all this. How long does the positive feedback loop continue? Until the quote unquote job gets done. So it's going to keep on going up, stronger, faster, stronger, until the job gets done, whether that's the baby being born, or if you're a cut on your arm, once it's healed, then these platelets will start showing up. Those are both examples of positive feedback. What are 2 ways that humans can lower body temperature? We've already done it twice, right? All right, we'll do it one more time. All right, sweat and blood vessel. I'm not going to spell dilation because I don't know how to spell it. Let me try it one more time. Dialation. Still not right. You guys figure, I think that's right. All right, the slug, he's being salted, not assault. Okay, that's kind of a joke, I guess. Snails and slugs are similar to cell membranes. So what causes the snail to die? Well, if you pour salt on them, just like a cell, so now that he leaves like a trail of slime, but now that his slime is going to be full of salt. So it's going to be more salt inside his body than out, or more salt outside his body than inside. So it's going to cause water to leave his body. So basically, the salt creates more solutes outside his body, and water will move out. The water will move out through osmosis. So it basically sucks all the water out of him. That's how he dies. But don't do that. It's kind of, that's not really nice to do that. All right, the beaker above contains dialysis tubing that has little tiny holes in it that allows glucose can move in and out of the bag. Water can move in and out of the bag. Starch cannot because it's too big. So it's stuck in the bag. It can't get out, and it can't go in either. The tubing is placed in a beaker with 100% pure water, 100% water out here. The dialysis bag, tiny holes, I said that. All right, so starch is too big. So since the dialysis tubing allows certain substances to move in and out freely but blocks others, we say that that's called semi-permeable. Remember, it's also called selectively permeable. In the beaker, glucose would move out of the dialysis bag, so it's going to move out. So glucose, there's a lot of glucose in here, none out here, so of course it's going to move out from high to low concentration. And since that's glucose being moved, that's diffusion. Water is going to move in from 100% water to very, very little water in here. It's going to move in, but remember, since it's water, that's osmosis. All right, now the graph. Which graph is it? So if you look, water is going to move into the bag from high to low concentration. Glucose is going to move out of the bag from high to low concentration. So the amount of water in the bag is going to go up. The amount of glucose in the bag is going to go down because it's going to be moving out. Starch, on the other hand, is going to stay the same because it can't get out. So whatever you start with, you're going to have the same amount of starch inside that bag. So we got to pick the graph. So first, let's find the one where starch stays the same. So starch is red. Okay, so we got this one, starch stays level, doesn't go up or doesn't go down. And same with this one, starch stays level. So we know it's one of these two. This one is wrong because starch goes up. More starch is in the bag. Well, that can't happen because starch can't go into the bag. And this one, starch is going up again. So these are no good, no good, no good. Now let's see these two. Remember, water is going to move in. So the amount of water is going to go up. And the amount of glucose is going to move out. So the amount of glucose is going to go down. And which one has water going up? Right here. Water's going up in the bag and glucose is going down. Here's your answer right there. That's the correct answer. All right. Why did you choose that graph? All right. I'll just say it. Because starch stays the same, water goes up, and glucose goes down. And that's what would really happen. I ran label these things. I didn't have a word bank. I probably should have. But you'll see the same picture on the test. There will be a word bank. Number one, the green molecule that's going to fit right here on this enzyme, that's called the substrate. Substrate. Two, that's the spot on an enzyme that has the perfect shape where the substrate's going to fit in. That's called the active site. Three, this gray blob. So it shows you from start, then to finish. So that, everywhere here, 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 and here, that's the enzyme. So that gray thing, that's the enzyme. And four, the blue and the yellow thing, the thing you make, whenever you make something, that's your product. That's what you produce. So that's the product. That's what the enzyme made. Product. All right, so the enzyme turned this green substrate and it made this blue and this yellow product. I think that's it. All right, so hopefully you understand most of that and you'll do well on the test, and I'll see you next week.